Hey everybody, welcome back. As promised, we are going to do no new videos. Well, okay, let me rephrase that. We're going to do some new videos, but there are going to be no new reactions. I sent out all the reactions for your toolkit yesterday. Thank you all for either your panicked freak out response or your just passing out from the anxiety. I'm not sure which it was, but either way, I appreciate some sort of action. Now, what we're going to talk about today is we're going to talk about multi-step and some tricks. Just things that will help you in the future. Now, one of the tricks we've already talked about, and that is a dummy meta director, which is something like sulfonating your ring, SO3 and H2SO4, putting that on there, doing a reaction, let's say, let's isolate it. For those of you who love details, yeah, you should probably use 2 equivalents of aluminum trichloride there because one of them does get bound up in the carbonyl oxygen, but that's the least of my worries if you want the truth. So now we got this, we have this here, and now we can iodinate it. Which puts the SO3 here, there, iodine there, aromatic ring, and then you can get rid of the SO3 by reducing this with just water and dilute sulfuric acid. The SO3 comes off the ring, and you go back to benzene, and then you realize that was a really shitty example you just picked there, Dr. Weigel, because the ketone there was already a meta director, to which I respond, hey, I'm operating on like 2 hours of sleep from last night. I had 2 birthdays in a row for my kids, and yeah, I just kind of feel like crap. So we're just going to move on to a different example. But don't worry, I have some more coherent examples we can work on. I believe I left you yesterday, or in the last video, with this. Starting here, I wanted you to go here. That was what I wanted you to make. No, absolutely not. I didn't forget that last CH3 of the ethyl group. You forgot the last CH3 of the ethyl group. What are you talking about? And I asked you, starting from benzene, to go ahead and make this. And I believe I also said, please don't overcomplicate this because it doesn't need to be overcomplicated. Here's how I would have done it. Now, hopefully, those of you that are trying this, or at least thinking, hey, I really need to study for my organic final on Thursday, it's due Thursday, why don't we just start it at 12:01 a.m. on Thursday morning? That's a great idea, isn't it? So I would start with this 3-carbon acid chloride and aluminum tri. And now you are here. All right? Then we use a base. Honestly, in the case of aldols, you are happy to use just B. I'm not going to get too hostile because hydroxide does work. It's slow. So do alkoxide. So does LDA. So does NaH. And honestly, with all the other shit we have going on, I don't care which one of these you use. So now we're here. We've generated our enolate. And the enolate will then attack another one of the ketones. Reform the pi bond, nucleophilic attack, open the pi bond, aldol addition. Remember, this is, you don't have to show mechanism for multi-step. I just like to sort of lay out how I did it, at least the first time. So now we're here. We're like this. And then we lose the OH. And that puts us here. All right, so now I want you to work on one. And this one is going to be a few more steps. It's mostly EAS reactions and then playing around with them a little bit. So I want you to start with benzene here, all right? And what I want you to do is turn it into this, meta-hydroxy benzoic acid. Meta-hydroxy benzoic acid. Go ahead and take a run at this, and then we'll talk. All right, so here are a couple clues on how to do this one. First of all, as always, look at the aromatic ring and see what the attachment is between those three groups. This is a meta association with each other. So now let's look at the two groups that are attached. The OH here, this is an ortho-para director. Now this acid up here is a meta director. All right, so we're kind of onto something here. But there are a couple other hitches here I want you to be aware of. Thing one, do you know how to put an OH on a ring? What do you think? Do you all know how to put an OH on a ring? Now, this is the point where some of you are going to be frustrated and look at this and throw your hands in the air and say it doesn't matter and how I'm a meanie and all kinds of bad stuff like that. So the question remains, though, do you know how to add an OH to a ring? Well, the answer to that is not directly. However, there are some ways around this. For instance, if you wanted to add an OH to a ring, what you had to do was you'd go from benzene to nitrobenzene to aniline to nitrous acid to phenol. Now, here are all the steps for this. Nitration, HNO4, HNO3, H2SO4, reducing to the aniline, tin, and HCl. And going over here from the diazonium to the alcohol, the phenol, it is acid, water, and heat. All right? Now here's the problem with that. That is a meta, that is an ortho-para director. So because the product is meta, you don't want to put that on there first. So instead, why don't we think about this? How do you know of to make a carboxylic acid group? on a molecule? Well, there are two possible ways that you might know of to make a carboxylic acid. One of them involves taking an alkyl bromide, reacting it with magnesium metal to generate the Grignard, react this with solid CO2 to generate the carboxylate anion, and then add some acid to make it the carboxylic acid. Now that will work. You've got your CO2H group on there, and now this will be a meta-director, which means that your subsequent reaction of nitrating it the acid group will force the incoming nitro group into a meta position. And from here, you just do all the rest of this crap from here over. All right? So there you go. Now, I want to leave you with a puzzle that we're going to talk about immediately in the next video. No, really, I promise. It's this. I want you to think how to make this molecule. Para-nitroaniline. All right? I want you to think about how to do this. It's not as easy as it looks. There's a couple extra steps involved because here's what you might be thinking. Well, the positioning here is para. The NH2 is an ortho-para director. The NO2 is a meta-director. How do we put an NH2 on a ring? Okay, blah, 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 blah. I will go ahead and show you that this won't work. Then reducing this to the aniline. Now, I can already hear a couple of you out there saying to yourselves, why can't we just nitrate it twice off that first nitrobenzene there? Well, the reason we cannot do that is nitro is a meta-director. So if we tried to nitrate it again, not only would it be slower because nitro is a deactivating group, but this would be the product you'd make, which is not what you want. Now you get to this aniline, you know that aniline is an ortho-para director because it's in that strong ortho-para director list. And you might think to yourself, well now I'll just nitrate it again and make this. The problem is that will not happen. The product you will make instead is this. And we'll discuss why and what you can do about it in the next video.